I'm going to discuss how to write down the torque equation. And the definition of torque is the magnitude of torque acting on a body about a point, let me call it as O, about an axis passing through the O, then I'm calling it as tau. O is equal to F bar RS force into perpendicular distance between the axis of rotation and the point of application of force. So torque, we can write it as force into perpendicular distance between the axis of rotation and the point of application of force. And I'm calling it as F into R perpendicular. So to understand this here, simply consider this diagram. So here this is the axis of rotation. Okay, here there is a particle P of mass m. This is the axis of rotation. The distance of the particle from the axis of rotation I'm calling as R. Now, here there is a force acting on this particle at an arbitrary direction like this, where the angle between the force and this axis of rotation, I'm taking it as theta. Here, for calculating the torque about this axis of rotation, let me call it as O, you can proceed it in two ways. Either by considering the perpendicular distance of the line of action of force, that is, extend this force and drop a perpendicular from the axis of rotation to the line of action of force. So if this distance is r, if this angle is theta, this angle also theta, because of which component of r in this direction, let me call it as OA. OA is equal to what I can write? R sine theta. This distance OA is also called lever arm. That is equal to what you can get? That is equal to F into perpendicular distance from here to here is how much we got? R sine theta. So F into R sine theta is the torque acting on the body about. Alternatively, there is an intuition provoking method of writing it, because component of force along this R bar is how much? That is in this direction, it is F cos theta. So line of action of this F cos theta passes through the axis of rotation, because of which torque due to this force is 0, and component of force perpendicular to this R bar, that is F sine theta. So only force which is producing torque is the component of F sine theta. Alternatively, you can write down this torque as torque tau is equal to S, perpendicular distance between force and the line of action of force, that is R, and the force which is causing torque, that is F sine theta. Whether you write the length of the lever arm into force or the distance of perpendicular component of force to the position vector, whether you write by this way or this way, in both the ways you will be getting same answer. So to understand this even more better way, here I would like to consider a situation in which there is an arbitrary shaped object, heart shape. I am taking an arbitrary shape of irregular shaped body like this. Okay, so this is the center of this body. So from here, at this point, a force is acting in this direction. Its magnitude, I am taking it as 10 newtons. And distance of this line of action of force from this center, I am taking it as 4 centimeter. And somewhere over here, there is another force acting on this body, that is in this direction, whose magnitude is 5 newtons. And this distance, I am taking it as 6 centimeter. and this angle is given 37 degrees. And here there is one more force acting on the body, okay, in this direction. Its magnitude I am taking it as 20 Newton, and this angle is given as 150 degrees, and this distance also is given 4 centimeter. And here there is one more force acting on the body, and its direction is like this into this, and its value is 50 Newton. And this distance some 8 or 4, something like that you take it. Now I want to calculate what is the resultant torque acting on this body about this point, that is O. With respect to an axis passing through the O, what is the torque acting on the body? If there is only one force, we wrote it like this. What if there are more than one number of forces? In such a case, simply do one thing. Calculate the torque due to each and every individual force and sum it up. Add it up, we will be getting the answer. So for this purpose, here the axis of rotation that I am considering is O, that is passing through its center and perpendicular to the plane containing this diagram. So before that, first we should look at the sense of rotation produced by each and every torque, each and every force. For example, if you take this axis, this 10 Newton force, as it is pulling in upward direction. So if you fix this body at O, in which sense this body can rotate? In clockwise sense. So this 10 Newton force is producing a torque in clockwise sense. And this 5 Newton force, how to write down? Instead of going through this line of action method, I would like to consider the component of force method. So component of force in the direction of line of action is given by, this is the line of action direction. So the component of this 5 Newton force in this direction is how much? If this angle is 37, then this is 5 cos 37, and torque due to this line of action is passing through 0, so torque due to this force is 0. And component of this F perpendicular to this line O, this line is component of 5 is how much? 5 sine 37. So this force, this component is applying force in this direction. So with respect to O, this body can rotate in counterclockwise sense, that is in this sense. Next, let us come back to this 50 Newton force. The line of action of this 50 Newton force is passing through the axis of rotation, because of which torque due to this force also. And let us come back to this 20 Newton force. Again, what should I do? I will resolve this force, the component of force, parallel to this position vector, parallel to this, and perpendicular to. So if this angle is 150 degrees, this angle also 150. So component of F in this direction is how much? Or else if you take this as 150 degrees, this remaining angle will be how much? 30 degrees. So component of F in this direction is F, that is 20 cos 30, which is in this direction, and it is passing through axis of rotation, line of action, because of which it is 0. So component of this 20 Newton force normal to this position is given by 20 sine 30. Okay, so in which sense this is rotating? This torque produces this torque, this force produces torque in which sense? In counterclockwise sense. So while writing the torque equation, either you take clock as positive, anti-clock as negative, or anti-clock as positive, or clock as negative. Once you make that convention, you should stick to it. But in general, in physics, we consider this counterclockwise torque as positive. So what are the forces which are producing torque in counterclockwise direction? 5 sine 37 and 20 sine 30. These two forces are producing torque in counterclockwise, and these two torques I am taking positive. And this only force that is producing clockwise torque is 10 Newton force, that I am taking as negative. So torque due to 20 Newton force is how much? 20 sine 30 into, what is the distance between the axis of rotation and this force? That is 4 meter into 4, plus next this one 5 sine 37. This distance is 6 centimeter. 5 sine 37 into this distance is given how much? 6 centimeters. These two are in counterclockwise sense because of which I am taking it as positive. This is in clockwise sense because of which I am taking it as negative. Minus, this is 10 into the distance between these two force and axis of rotation is 4. This is the expression for net torque acting on the body about O. So be careful. Here the distances given are in centimeters. So because of which you multiply this whole equation with 10 power minus 2 because force in Newton SI unit, distance is in centimeter, CGS unit, you should convert it into that. So the next thing is simplification process. So 10 power minus 2 into 20 into sine 30 is how much? 1 by 2 into 4 plus 5 into sine 37 is how much? 3 by 5 into 6 minus 4 is equal to resultant torque acting on the body through. So 2 ones are 2 twos are 22s are how much? 40. Next 5 gets cancelled. 6 threes are 18 minus 40 into 10 power minus 2 is equal to resultant torque acting on the body. So this minus 40, 10 plus 40 gets cancelled. 18 into 10 to the power of minus 2 Newton meter. This is the total torque acting on the body. This is how we can calculate torque acting on the object when more than one force is acting on the